you cannot put a dash in the file name, and it can't be a name over which Excel already has a property rights. You cannot call it log, because that function already exists. It is optional to type the inputs, but it's always a good practice as a programmer. I'm gonna make that into a double. Double is a data type. That's basically double precision real number. Roughly speaking, a double precision number is represented correctly up to about 15 significant digits. Okay? For example, 0.1 is plus 10 to the power negative 16 is going to be in computer exactly 0.1. In computers, there is something called machine epsilon. It is such a number that it is the maximum number you can add to 1 and still get 1. Because computers, at least these computers, cannot represent numbers in infinite precision. But for all purposes, even single precision would be fine, 7, 8 digits. So double is good. And cache is one of them. I'm gonna have, I could either do this with period rate or APR, but since I'm gonna use this kind of as an intermediate thing, I'm gonna do it with period rate. So I'm gonna call this P rate. That's also a double. I'm gonna have I time, the length of time for which I'm doing the discounting. Again, I allow that to be a non-integer number. That's pretty much all I need to calculate present value. And I want the result to be a double precision number as well. It automatically adds a line that says end function. That means any code that I'm going to write in between is the definition of that function. And if you want the number that's going to be returned to the entity that calls this function, which could be either a spreadsheet or another function in VBA, that's going to be stored in this thing called PV1Flow. Okay? In this case, it's simple. Well, by the way, it's always a good idea to write comments. Any line that starts with a single quote is considered a comment line, and it's completely ignored in execution. It's basically your message in a bottle to yourself, especially when you're debugging a code. You kind of should know exactly what you were trying to do. Sometimes you don't achieve that, but if you remember what you were trying to do, that helps. Again, these tabs are completely optional. I do it for my own purposes. This function calculates present value of a single cash flow given a discount rate for period, not APR, and length of time for discounting. In this case, definition of the function is simple enough. PV1Flow as you have seen, I wrote everything in small caps, and it's going to be iCache times 1 plus P rate raised to the power I time, right? You know, not times, divided by, I'm sorry, since we're doing present value. Did you see what happened to the capitalization once I entered it? If the variable was already defined, it changes the capitalization. If it doesn't, you've done a spelling error. Now, if I had written this as my timer, see, nothing changed on my timer. That's why I use those weird capitalization in the definition of the variables, so that I can catch any misspelling I may have had. I am done. You know, this is a simple enough function. It takes one line. Before I do another one, I need to tell you what this equality means. That equal sign does not say those two sides are equal. That's called in computer language an assignment operator. Here's what this statement means. There's a place in the memory that is tagged iCache. Go there, grab its value. Do the same thing for P rate and I time, okay? Then do that calculation. Whatever that result is, take that, go to the location in memory that is called PV1 flow, and put that value in that location. That's what that equal sign means. It's an assignment operator. Understanding that's what it is becomes handy when you do things in loops, which we're gonna do next time. But since I'm already here, I'm gonna go ahead and I'm gonna do an FV1 flow. Since I'm doing futures, I have to multiply it with that factor. So now I have two little functions, that's going to calculate either the present or future value of a single cash flow. I'm going to close this. Let me show you how you can actually use that. For example, I used a formula in here, right? So let me just go ahead and do this. I want to calculate that PV using the function I just did. If you don't remember the syntax, click on the FX button, okay? On the category, hit user defined. It's going to give you all the user defined functions. Again, I don't know why this computer has a lot of function names that are in Dutch. But in this case, here's my PV1 flow. You can kind of start typing the name PV. That's what it is. Okay, it has 3 arguments. That's my cache. That's my period rate. And that's my time. In fact, let me do it here again. Or just to show you, let's say I'm doing the future value. I want the future value of that quantity using that rate and using that much. If you've done everything correctly, it immediately tells you what the answer is right there. If that number is, this space is empty, there is some sort of error. Okay? Obviously, this is simple enough so that we don't have to, we're just checking. I'm going to stop here. On Monday, we're going to basically write a function for present value for growing annuity with all the bells and whistles, and it may have non-integer last period and so on. If you have the present value, calculating the future value, I don't have to even write a separate code for that, but I will. That's going to be easy. Then we can use that in our solver to solve complicated planning problems that involves growing annuities. I'll see you guys Tuesday.